Good morning, everyone. This is Prasad Toluri, postdoctoral researcher at UCT Prague. Today, I would like to discuss about my work, high performance membranes for separation of biofuels. Currently, I am working in production of biobutanol and separation of butanol from fermentation media, that is like renewable energies. Why renewables? Because they do not deplete natural resources. And today, one of the major problem is global warming. So we can reduce the global warming by using of renewables, and it is one of the effective method to reduce CO2 emissions and guarantee energy securities for next generations. And coming to the butanol characteristics, butanol is a colorless 4-carbon alcohol. It can be produced through either chemical or biological method. And butanol is considered as a potential biofuel because you can use the biobutanol in cars or any engines without any changes to the engine. And it contains more energy for a given volume than ethanol, almost as much as equal to gasoline. Why butanol? Because of the low solubility in water, transportable in existing petroleum pipes, and blendable at refineries, low vapor pressure, and usable in gasoline at any blended ratios. Coming to the production of biobutanol by fermentation, there is one of the effective method, that is ABE fermentation, acetone butanol ethanol fermentation. So mainly two kinds of anaerobic strains were used in this ABE fermentation, that is Clostridium acetobutylism and Clostridium benjerici. The main challenges we are facing in biobutanol production is the selection of biomass, that is like the energy source, carbon or nitrogen source for the production of biobutanol for anaerobic bacteria, and low concentrations of production, like products of butanol. Product toxicity microorganisms, we call it feedback inhibition. The product which is produced by microorganisms show the effect on the same microorganism. And shear stress because of these bioreactors, impellers which are used in the bioreactor. And another main problem is downstream processing, that is the separation of butanol from the fermentation media. Mainly the fouling problem with membranes. As you expose these membranes for a long time to this fermentation media, it shows some effects on the membranes. My current research work at UCT involves in three labs. One is microbial process lab, where we use the maintain the microbial, where we like selection of biomass and production of biobutanol ABE fermentation. And coming to the mass transfer lab, where we use like design the bioreactors which are suitable for growing anaerobic bacteria. And mainly my research was involved in membrane separation lab, where I designed membranes and custom-made per operation device for separation of biofuels like the solvents from the fermentation broth. And we use like synthetic ABE model as well as binary solutions like butanol water, ethanol water for separations. Coming to the per operation system, what I used in this current research is completely, you can see here the schematic drawing of this per operation system. It is completely the self-developed custom-made apparatus, and you can see here like it consisted two detachable parts made of duralumin. One part like is it's for like to hold the feed solution at atmospheric pressure, where we use like continuous stirring with the help of magnetic stirrer. And the other part, the second part, is provided to for the sweeping of the permeate with sweep gas. We use a nitrogen as the sweeping gas at atmospheric pressure. And the membrane which we used in between these two parts is the area of 2.3 centimeters square. And the whole apparatus we maintained at the constant temperature using water circulator. We use a PTMSP membrane for the separation of water butanol system solvent, and we use like MTBE solvent for the preparation of PTMSP membranes. The thickness of the membrane is around 46 micrometers. Coming to the experimental conditions, the experiments were performed at three different temperatures, 37, 50, and 63 degrees Celsius, as well as at three different feed concentrations, 1.5, 3, and 4.5 grams, like weight by weight percentages. And we use liquid nitrogen for the collection of permeate, and the molar fractions of butanol and water in the feed, and the feed was analyzed by using gas chromatography, as well as the feed which contains yeast extract was like analyzed by using HPLC. Measurement of transients per operation. So we use FTR for the measurement of transients. The stream of nitrogen containing permeate escaping from the perforations continuously analyzed by FTIR equipped with MCTA, that is mercurium carrying interlate detector, and the approximate volume of this gas cell was around like 0.25 cubic decimeters, and the nitrogen flow rate was maintained at 75 centimeters cube per minute. And the bands we use it like the for the series, the collection of series we use the banding range for butanol is like 1146 to 974 for the butanol. And you can see the peaks like the bands here. The first one, the red color one is for one butanol, and the violet color is one for water. And this is the band range. So measurement of steady pair operation. We measured flux as well as separation factor, and separation per operation separation index, that is PSA. As also we analyze the permeability according to the Baker's equation. The Baker's given equation for the separation like to calculate the permeability. So we use the Baker's equation for measuring and analyzing the permeability. Coming to the results, we studied perforation at three different temperatures at three different feed concentrations with each extract, without each extract over a period of 80 days after the membrane was soaked in the ethanol. So within the tested time period, like the first 28 days without yeast extract and up to 80 days with extract after being soaked in methanol, if you see the flux results, the total permeate fluxes decrease almost like 50% decrease, especially in case of experiments at 37 degrees with lesser, as well as if you see the flux results was like lesser decrease were observed in experiments where more concentrated feeds at higher temperatures. You can see in the above graphs that the decreasing of fluxes like at 37 degrees, 50 degrees as well as 60 degrees. If you see the graph at 63 degrees, especially with the green color line, like 4.5 weight percentage of feed concentration, it shows like straight line. That means the fluxes were like lesser decrease of fluxes was observed in higher temperatures at higher feed concentrations. Coming to the separation factor and selectivity results, neither feed concentration nor temperature, time, or the presence of yeast extract in the feed doesn't show any influence on separation factor as well as selectivity of PTMS-P membranes. The average separation factor was around 82 and selectivity was around 2.6, and they remain practically independent on the process conditions tested. The lowest separation factor and selectivity observed at higher temperatures and higher feed concentrations. Coming to the permeability results, the permeability of both 1-butanol as well as water decreases noticeably over time at lower feed concentrations and lower temperatures, that is like 37 degrees and 1.5 weight by weight percentage as well. And no other systematic changes in the permeability of PTMS is apparent. So you can see here in the graphs like 37 degrees, 50 and 83 degrees at the three different feed concentrations. So coming to the diffusivity of 1-butanol at different feed concentrations and temperatures over time, you can see on the above graph, similar to the total power operation fluxes which appear to be most influenced by polymer aging in the case of experiments conducted with dilute feeds, that is 1.58 by weight percentage of butanol at lower temperatures, that is at 37 degrees. The diffusivity of 1-butanol in PTMSP were almost influenced by aging at lower temperatures. This presumably was due to the fact that decay of the free volume voids was not counterbalanced by plasticization of the polymer under these conditions. And in the below graph, you can see the per-operation transients analyzed by using FTIR, and the straight lines indicates the feed without yeast extract, and the dotted lines indicates the feed with yeast extract. The per-operation transients observed for the experiments at higher temperatures were more rapid. The addition of yeast extract didn't result in significant changes in the transients, while the effect of aging of the polymer was more pronounced. Here in this figure you can see the content angle measurement images of both fresh membrane as well as aged membrane after 80 days of testing membrane. And if you see the differences, the content angle was slightly decreased around 5 degrees angle in the aged membrane compared to the fresh membrane due to because of aging of the membrane. Coming to the conclusion, in the present work, the transients and steady-state per-operation of 1-butanol and water mixtures through a PTMSP membrane has been studied in a continuous series of experiments over a time period of 80 days under the conditions of like different temperatures, like 3 different temperatures and 3 different feed concentrations, with addition of yeast extract, without addition of yeast extract. And while the total fluxes and individual component permeabilities decreases with over time to a limited extent. And coming to the separation factor and selectivity was average 82 of separation factor and selectivity is 2.6, appeared practically independent on the process condition. As well as coming to the aging of polymer was most pronounced for experiments with lower feed concentrations and low temperature, while it is counterbalanced to some extent by plasticization of polymer with 1-butanol and more concentrated feeds at higher temperatures. Overall, this is one of the new methods for measuring steady and transient per-operations, enable a detailed examination of mass transfer to one of the best performing polymers for per-operating separations of mixtures of water and 1-butanol binary mixtures. Thank you. Thanks for your attention. Finally, I would like to grateful to my mentors as well as my funding agency. Thanks everyone.